Hello, everyone. Good afternoon.
Oh,
Hello,
Hello,
everyone.
good afternoon.
good
Good
afternoon, good
afternoon if you are in
morning.
Nigeria. You are welcome to our third quarterly webinar in 2025, organized by Black in Mathematics Association. So before we start, I would like to welcome all our participants as well and just have a little short introduction. Then let me start from me. I would like to introduce myself. I'm Dr. Idayat Usamot, a lecturer in the Department of Mathematics, University of Ilorin. So the floor is open to all our participants as well to introduce themselves. So I will start from Mr. Abiodun Ajani. Can you please introduce yourself, Mr. Abiodun
Yes,
Ajani?
ma'am. I am Abiodun Ajani, ma. Good day, ma.
Okay, you are a woman.
Yes, ma.
All right, you are welcome. You are
Thank you,
welcome.
ma. Yes, ma.
Over to you, Mr. Adeoye Abiodun. Mr. Adeoye Abiodun, are you there?
Good afternoon, ma.
Good afternoon. You are welcome.
This is Ade Komodin Abiodun, ma. Yes, ma.
All right. From which university?
From Osun State University.
Okay, you are welcome.
Yes, ma.
Over to Mr. Adejimi Adeniji.
That's our convener, BMA.
Oh, you are welcome, sir. Well done. We really appreciate you for your job well done. Oh. Thank you so much. So once again, I welcome everyone to today's webinar. Now, before we start, I would like to now introduce our speaker for today, which is an erudite scholar, in person of Mr. Toluwanimi Idowu. So let me go to his read his citation. And before that, the topic for today is the math behind artificial intelligence. I want us to sit back. Today's topic is going to be an interesting one, and we are going to gain a lot. So take your pen and your jotter beside you because you need to jot down some things. And any question you have, I want us to jot it down at the end of the presentation. So if you have any question, to ask our speaker, that I'll be able to ask them. So let me go straight to introduce our speaker properly by reading his citation. Mr. Toluwani Idowu is an audit and assurance senior associate at Deloitte with a strong foundation in accounting and financial reporting. He holds a master's in accounting from the University of Illinois, Springfield, and a bachelor in accounting from the Federal University of Agriculture, Abeokuta. He is an associate chartered accountant, ICANN, and FMVA. He has worked in both the US and Nigeria. You will see that our speaker is an erudite scholar, gaining experience in financial reporting, reconciliations, audit, and assurance through roles at Sahel Capital, City of Springfield, 63 Web Studio, and Mozilla Motors. Mr. Toluwani is passionate about applying accounting and finance to deliver insight and business value. So to our speaker, so the mic is yours. You are welcome.
Um, Good morning from this side.
Good morning.
Can you hear me?
Yes, loud and clear.
Okay. Okay, yeah.
Yes.
Okay. Good morning. My name is, like she said, my name is Toluwanimi Idowu. Currently residing in Dallas, Texas, and I work with Deloitte as an audit and assurance senior associate. Basically, like she said, I feel honored to be here today. I feel happy. I feel great to be able to do this today because ever since the strong emergence of AI, I've been so passionate about it, and it's been something that I really take so much passion in and so much interest in. I leverage the use of artificial intelligence in my everyday life, and also when I was contacted about this, that I'll be talking about this, I was nervous, and I was actually happy also. Nervous in the sense that, okay, I'll be talking to professionals like in the math field, and I'm like, oh God, what will I talk about? How is this going to be and all? But I'm like, yeah, let's just do this thing. Like, we're gonna do this and it's gonna be fine. So thank you once again for the opportunity to be able to do this. I'm really honored, and I'm happy, and yeah. And also I hope I very sure we're gonna have a great time discussing this, and I'll also try as much as possible to be able to blend in some other things into it so we can all understand, in case there are some people that join that are not like mathematically inclined. Because um when this was posted, I saw some people like reposting, liking it, and I'm like, okay, maybe if they join that are not even in the math field, like even if they join, they will be able to, like, understand what we are talking about today. And also, since I'm not like a math person, like I'm not fully into math, I'm trying to like blend in everything I know about it, like based on my own research and based on my own personal knowledge and all, like, and personal research and all, like blend everything together to make it like a whole, like try and get everything together and then make it more interesting for every one of us to be able to learn from and also like gain something from. And without wasting much of our time, I think I can start off with the presentation. Am I correct?
Yes. You are.
Okay. Yeah.
The floor
Thank you.
is open. Yes.
Thank you so much. Thank you so much. Um, Not too much slides, not too much to talk about, not too much slides, but there's so many to talk about. But I'll try as much as possible to um, be concise about it. Not too, I wouldn't want to talk too much, and I wouldn't want to hold back on some things. So today we'll be talking about the math behind artificial intelligence. And truth be told, this is something that we use virtually every day, and we've been using it even before we can, before it gained this so much. What do you call it? Before it gained this um, popularity. Let me use the word popularity. I was trying to look for something else to use, but let me use the word popularity. Most of us we've been using artificial intelligence, but we just don't know because we never thought about it as being AI or something like that. We've used it in so many ways. We've it has helped us in so many in different ways. But today we're talking about the math behind it. Like, there are some things that actually come together to make up this math, to make up this artificial intelligence. And yeah, like I said, introduction, I've introduced myself. We're talking about how math has actually helped in AI, the math behind it, and all those things like that. And I want to like ask us, like, I know there have been, well, from my own personal experience, when I was very small, I was very curious. Like, I don't know if there are so many of us that are like that when we're small. I was very curious. I always wanted to know what's going on behind the scene. Like, how does this thing work? What's the rationale behind it? What's the notion behind it? How does this thing work? Like, what's going on? And one of the examples I always remember that I still discussed with my wife like some days ago, like I was still telling her that, oh, that there was this time when we were small, and then we had this remote control. Like, that was when this remote control TV came out and all. I was still very small, like primary school, as we'll call it there. And myself and my brothers were now testing the range of the remote. We're like, okay, if we sit here, if we press it, will it work? If we sit here, we press it, will it work? Until we had to go, and we stay in the story building, we had to go downstairs in the compound, and somebody was in front of the TV. The other person was at the balcony, and the other person was downstairs with the remote and was pressing. I was like, is it working? Is it working? Is it working? And we're like, no, it does not work. Then we found out that, okay, this thing works with proximity. And then, oh, until we now like grew up, and then we now found out that, okay, it works with infrared. Like, you need to point it to the TV before it works and things like that. And we're like, oh, okay. Until now that it's now started, like they started increasing the range. Like, some remotes for your garage, when you want to like come into your garage, like they use here, just press it from your car, even when you're like some blocks away from your house, and then your garage door opens, and then just driving, and then you close it back and all. So we can see that things actually like things gets to like what do you call it, start to develop. And as people would say, there is nothing new. It's just like you trying to like improve on all those things. So like I said, there's been AI way back, but most of us just didn't know. We didn't pay so much attention to it. We didn't just see it as like, okay, this is artificial intelligence until it started getting its popularity like 5 years ago. Like that I would say, like it started getting popularity and everybody started feeling like, okay, and then we started leveraging it in our work, in medicine, in everything. Like you can literally see AI in everything we do right now. Phones have AI installed in them. Phones, cars, everything. Like even in medicine, we can see the use of AI. Even in movies, like it's been so long. Like there's something I was watching a movie, The Matrix. If you look at it, they discussed AI in it, like they discussed it so much, but we just didn't know because we were like, okay, it's just one of those movie fictions, like one of those fictional things they talk about in movies and all those things like that. But that's just it. So let's move on. So I just wanted to start off with the definition of this AI because I wanted to use something else, but when I saw this, it encompasses so many things. Like it's combine almost everything that we're going to talk about, like everything that AI talks about. They said it's the tangible reward capability of non-human machines or artificial entities to perform tasks, to perform tasks, solve, communicate, interact, and act logically as it occurs with biological humans. Like everything humans do is what AI is doing. And they said non-human machines, like and artificial entities, we are all there, like we all know. They say, oh, natural and artificial. So that's why they said artificial entities, like they do all these things, they task solve, they communicate, they interact, and that is what we are doing basically with AI today. It helps us solve tasks. We communicate with it, like we tell it things to do, like okay, we interact with it and tell it, okay, this is what you want, this is what, and then also act logically. And the way we humans do, like that is how it is. And common example is the one we all know, like Siri on our phone. Though we have like we can actually break it down into other like subsets. Like we can say, okay, maybe this is natural language processing or things like that. But the general example, the reason I'm using this is just to, like give it a general example, like okay, Siri, Alexa, ChatGPT that we all know about. Like I'm not seeing some, well, maybe from my side, but I don't think I've not seen anybody that does not know ChatGPT. Like everybody knows Chat. That's the first thing that they will tell you that, oh, did you use AI? They will like, yeah, I use ChatGPT. Did you use, and there are so many like things that we can use. There's another one that we call Replit. Replit is like is I don't know if we all know it, but this is something I've been working with like for like 2 months now. I use it to vibe code. There's something we call vibe code in such that you do things like you can create your own app, like tell you what to do, like create your own app with Replit, and then it actually like works on it, create your website for you, create your based on the prompt you give it. Like you can also continue to make changes over and over again. Like, okay, I want you to add this and this and this to this, like to things like this, like so many things. Like it's just so interesting. When I found out about it, actually used it to build I used it to build two apps for myself. One for an application like that I'm working on, and the other one just for vibe, like they said, vibe coding. I was just using it to vibe. And in the vibe and all those things, I created like a website for what do you call it? For elementary school students that they can use to like help with the assignment and then help with daily tasks. Like, okay, today you have to study your math and then like daily task and then do everything and all. And then also we see it in self-driving cars too, using LiDAR. And then the common example, if you ask anybody about self-driving cars or these AI cars, first thing that comes to your mind is Tesla. Like, okay, yeah. Because if you look at it, Tesla now, like you can self-drive, it self-drives. Like I heard of the new taxi in Austin that talks about that. It's like it's a self-driving taxi, robot taxi, and things like that. So everything is just emerging. We can't see that there was no car before. There were cars, but now there's like adjective of like there's now something that is like making it more advanced, which is the self-driving cars. Like I said, all these things were in existence before. It's just the whole when you like add things to it that you make it like the whole it's just you advancing it that makes it like that's in like in vogue right now, like making it like become known and things like that. Now let's move to the next slide. So like I said, AI has been in existence before it gained its popularity. So like it has been in existence. Most of us just don't know. And one thing, I posted this thing on my LinkedIn page. I said Microsoft Excel and artificial intelligence, a love story that we never knew was in existence. And it's actually a love story because we never knew that it was in existence. Most of us were using what do you call it, Microsoft Excel. When I wrote my project, my undergraduate project in 2017, I used Excel also. Like I was like put all my data in Excel before I then moved it to SPSS and or to do the analysis and all, which I can actually do on Excel also. But if you look at it, Excel is something that is so relatable that we can just like we can sit back and when you sit back and then think about the Excel formulas, you are like, okay, this is what I've been using AI since. I just didn't know. Like it didn't just occur to me like this is what I'm using at this point in time. Like it didn't occur to us. But now that we've now seen the emergence of AI in its full glory, we can now then take a step back and then start looking at it like, okay, yeah, it's true. This thing was in existence before. Okay, and then before we know, and things like that. And if you look at it, like the formula is like the base, like the most basic thing that I can use to explain it right now. If you look at the if function, we can have an array of different things in our work, and then we just see, and then we just say, oh, if this equals to this, get this for me, and then it scans through everything the way AI would do if you put it on ChatGPT or something, minding your own privacy and security. Like I would say, when we get to that, I'm going to explain because I don't just want us to talk about the math behind it. We need to talk about like the things, the key to you to using AI responsibly. So we won't just talk about AI itself. We have to talk about how we use it responsibly. So when we get to that part, we're going to talk about it also. So using pivot table also, if we had to do those tasks, we would take so much time to do it. Like imagine you trying to sort data of a whole state, trying to categorize them into local government areas. You are going to spend so much time doing it. But with the use of Excel, we can actually just like pivot it, and then before you know, it's all done. Like within a matter of like seconds, your thing is just to get your formula right. Whatever you give into it is what you get out. Same thing with AI also, using the solver, using the goal seek formula. And this goal seek formula is just so interesting. Like it's like a cheat code to me. If I'm trying to do some math thing and then I'm trying to like A plus B equals to C, and I'm trying to like I have the answer for C, I have the answer for A. What should B be? I just use my goal seek formula. I don't need to see and then do if this one equals to X, take it to the other side, B minus C minus B equals A. Once I put it on GoSeek, I'm like it just brings out the answer straight up and things like that. So that's just it. So that's just like the basic introduction, the bedrock laying foundation for AI and how we've seen it in our everyday life even before it gained so much popularity over the years. Now, why math matters in artificial intelligence? Why does it matter in it? Basically, AI is built on patterns, probability, and optimization. That's like what it is built on, based on my use, based on my research, based on everything about it. It is built on all the patterns, like it follows a particular pattern. It's based on probabilities. Okay, if this equals to this, then this should be this. If this is this, then it's also based on optimization such that it's is someone saying something?
I think I've muted the person.
Oh, okay. So, like I was saying, AI is built on patterns, probabilities, and optimization. Optimization in the sense that it learns every day, like it wants to like improve on what you are giving it. Like, okay, this is what I'm doing, this is what I get. Is this answer correct? Can we move on to the next one? Is this answer correct? Is this answer correct? And things like that. So, and then we'll delve more into those three categories later on in the slides. Not so much, but we'll just talk about it. We'll talk about like those math models that actually like address these patterns, probabilities, and optimization. And some of us can actually like guess some of these things. Like for probability, we all know probability is like, okay, yeah. So that's just it. So let's move on to the next one. This one is just like a fun slide for me. I just had to include it because it's so interesting for me. I just wanted to include it. I don't know why I included it, but they said math is the language of intelligence. When I saw it, then I was like, okay, I'll agree with you on this one. It's the language of intelligence because going back, they didn't say math is built on economics and accounting, or it's built on medicine and philosophy and things like that. It's built on probability, patterns, and optimizations. And all those things are from where? They are from math. And I don't know if we've heard things like, oh, accounting is the language that the world was, teach everything is made. Like when you finish, you are going to give account, you are going to do this one. At the end of every day, you give account of what you do. You do this. People say different things. People have their own story to their own field of study. But this, they said math is the language of intelligence. And Galileo Galilei said mathematics is the language which God has written the universe. Because I think he said it based on like looking at the patterns and the way things actually work out. And then he concluded with this statement and said, oh, it's the language in which God has built the universe. So I said, concluding part of this, if you're a mathematician, give yourself a pat on the back because you are also a God. Truth be told, if not for you guys, we wouldn't be talking about artificial intelligence today. So this is like a thank you from me personally to all the mathematicians in the world. Like this is me saying thank you for using your knowledge of math to actually build something that will make the world a better place, that makes life easy for people. Even though people have different view about artificial intelligence and all, but so far you're using it the right way, you know what you're doing, you're actually on the right track. Like just enjoy it, savor the moment, enjoy it, and then use it to like this thing. And one thing I want to say again is that I remember when we were small, when we were in primary school, we would say, and even secondary school, now most people be running away from further mathematics. They'll be like, oh, what do I want to use math to do in this life? After my secondary school, I'm not doing math again in my life. I'm not going to touch it. And truth be told, I've seen people make that statement. I've heard people talk about it, like say things like that. But come to look at it, that thing that you said you don't want to use again for the rest of your life is what is saving you right now. Is like your artificial savior right now. Let me use the word. Is what is saving you, is what is making your life easy, is what is making you more efficient at work. So if everybody had made that statement at that point in time, there won't be any artificial intelligence today. So now let's delve into this, the building blocks of math in AI. We are making progress. Yeah. The building blocks of math in AI. Now, I was able to like check this out and I saw like three things. Like I said, also patterns, probabilities, and optimization. Now we'll talk about it from the side of the linear algebra, from the side of probability and statistics, and the side of calculus, which is like training models. Now it's these three parts. I will try and briefly talk about them. I may not go deep into it and then show all those what do you call it? I've forgotten more of this your formula but let's continue.
Integrals and all that.
Yeah, and yeah, thank you so much. Thank you so much. It's been a while that I did all these things. Maybe when my children when I start having kids and they start doing math, I'll try and remember.
You're doing a great job.
Thank you so much. So now we're looking at the building blocks of AI. What are those things that's like that they put together to like to form a whole, to form AI? Because like people, like they said in biology, like different cells, different components of the body make up a human. Cells, organs and tissues, bone, blood, water, everything. When you gather them all together, they make up human. So this is just like what are the things that make up human. This is like, it's just like the way Dr. Frankenstein, like we know in those movies, how we sat down and combined all those things together and then created this Frankenstein monster, like they all said in the movies. This is how somebody to sat down, also a group of people sat down and they thought about that. Okay, if we take this part of linear algebra, take the part of probability and statistics, take the part of calculus, let's join it together and then create something that we'll call AI and things like that. So that's what we'll be looking at right now. Now let's move into the first one, linear algebra. Now the first thing, some of us would know, like most of us would know, those that are like into math, like full math, this is just going to be like a walk in the park for you because it's like, okay, this guy's just taking me down memory lane, like, okay, or maybe it's what you're doing right now, but it's fine. Now, the first thing is like linear algebra provides a framework for handling and processing data in AI models. Like it's one of the integral parts of like AI. It's one of the integral parts. It helps in processing data. It helps in handling data. And some of the mathematical tools it uses is vectors and matrices. This is like when I saw this, I was like, oh God, I remember this matrix that it's like the brackets, and then you have the number 1, 2, 3, 7, 5, 7, and then they tell you that I should bring it out into the symbol matrix and all. Sorry, I don't know the mathematical jargons, pardon me, but we all know what I'm talking about, the old bracket, and then you put the numbers in it and things like that. And then we now move, and that's just matrices and all. And then this is used to manipulate and process data like complex models like neural networks. Like I said in the first part, there are so many things about like AI that most people just say, oh, AI, just complete it and say AI. But there is the natural language processing, there is neural networks, and a whole lot of them. But AI is like the umbrella name that people use to like categorize everything. They just say, oh, AI, and things like that, and all. Now let's I said by Kyle the other day, when he said that linear algebra follows AI, providing the mathematical tools and concepts necessary for data representation, transformation, optimization, and learning. So it's not just even about calculus, as even linear algebra flows into it. Like it helps in optimization and learning. Like I said, if you check the previous slide, I was saying that okay, like calculus in optimization and training models and all. But even linear algebra is one of those things that actually help AI to learn and then to transform data, to optimize, represent data, and also to learn. Now, this common picture, I was just looking for the best way to explain this thing, and this was what came to my head. If you look at a picture, I never want to edit pictures. It asks us like, oh, what is the pixel? And then 120 by 100, 70 by something like that. If we want, like for those of us that we did some applications online and they're telling us that reduce the pixel, reduce the things like that, it's just them breaking it down into the language they understand, which is what AI is doing also through the help of linear algebra. It breaks those things down into the best way that it can explain it and then work on it. And one of the common examples, not talking about AI right now, is the use of like binary. If for those of us that we like that actually like remember all these things or still that are still working on it, if you look at it, they said that binary zeros and one is the language of like, let me use the word, is language of the computer, because when you look at it, it breaks down like when a prompt is going through different phases in a computer system through the processing side, it's not what you see on the screen that like the computer has interpreted. It has gone through so many phases, but it's just like it was within a split second that you are saying all these things. Now, if we break this slide down into bits and all those things, you see the zeros and ones, like, but it's not something that we can see because it's not the language you understand. So this one, linear algebra, helps AI break down all those things into the format with which it will understand it. Like this example I gave, the example of the pixel, like it helps it break it down, and then you'll be able to like see, okay, so I can work with zeros and one, let me break it down into zeros and one. It's like when we try to like explain some things, well, for me, sometimes when I'm trying to like understand some concepts, I actually like sit down, I'm like, okay, they said this. How will I explain it to myself in Yoruba? How will I explain to myself in the language I understand? That is what linear algebra is helping AI do in this instance. Like, how do you explain it? How do you break it down to the language you understand before you now like give the response? I don't know if anybody has done that before, but me, whenever I'm writing exams sometimes, or maybe whenever I'm trying to like understand the concept in my exam, when preparing for an exam, and it's looking so hard, so difficult, I just sit down and I'm like, okay, how does this thing work? Okay, let me explain it to myself in the language I understand. Okay, they said this. So I break it down to myself in the best language I understand, so that whenever I see something, I can be able to like explain and then give the response to it. So that is what linear algebra is helping you do here. Break it down to language you understand for processing, for transformation, and then it also uses it to learn. Like in that process, it's learning also in case something like that comes up next time. It wouldn't have to like think too much about it. Just gives you like the answer, like, okay, this is it, just take and you're good. Now, I saw this from InfoSystem 2023. They posted like linear algebra, a bird's eye view, looking at it and how it extends into the whole machine learning, natural language processing, and all like that. Look at it. So we can see that the computational tool it uses like, let's see linear algebra at the base. Linear algebra is at the base. Then it now moves like all the other things coming out: vector, scalar, matrix, tensor. I don't, Dr. Idayat, and she will actually understand all these things, and other people that are on this, they'll be like, oh yeah, this thing is like a walk in the park for me. I still, who knows, she might have actually talked about this during a lecture yesterday. Nobody knows. And so this is just it, breaking it down and then like saying all the computational tool that uses, then now moves up into like, okay, delving into for problem solving, communication and natural language processing, knowledge and reasoning, learning via machine learning. Like that's just how linear algebra does its thing. Like provides the tool for AI, and then from there branches it out into different things that it's needed for. Maybe it's for problem solving or for knowledge and reasoning or for communication, and also that's just it. So without wasting much of our time, this is like for linear algebra in action. I know that there are so many things, there are so many scholarly articles talking about how linear algebra actually like is used in AI. And I would actually like say it's for the knowledge sake, we can just go check it out. You can go check it out. I myself, I have like some articles I downloaded. I'm still going to go back to read just for the fun of it, just for the knowledge sake. It's not going to hurt me getting to know it, because now that I'm talking about it, I can relate to some things. And I'm like, okay, so this is what we're doing when we're small, that we're like, oh, we'll never use AI again. But now we are using it and it's helping us make life easy for us. Now let's move to probability and statistics. Now, probability, it's like from the name itself, probable. Is this thing going to happen or not? It's just testing the likelihood of something, like will it work? Will it not work? Will this happen? Will it not happen? Probability. I know when we were doing it back in secondary school, when this topic was introduced to us, they were like, it's either going to happen or it's not going to happen. It's either 0 or 1 or something like that. They were just using different things to explain probability to us. Will it happen? It may happen, it may not happen. It's going to be on or it's not going to be on. It's going to be off, it's not going to be, things like that. So that's just what probability here. It's just saying that it's likelihood of an event occurring. And the way it helps is like it helps by modeling the likelihood of events, sequences, facial and speech recognition. Like, it just looks at the likelihood of event. That's how it's really, that's how it's AI is, it helps in AI. Excuse me. It helps look at the likelihood of events, like, okay, if this is this, that means it's going to be this. It's just like the if statements in Excel. If A equals to B and C equals to this, that means A plus this equals to this, then it will give you the answer. Simply put, it is used to make decisions and predictions. And also for statistics, statistics, like it's a word we hear all the time. Like this probability and statistics is what we hear all the time. And it's something that everybody, like, we all hear at every point in time, even if it's not in the math setting, it's not in the mathematical settings, it's in like even business settings, it's in like even medical field, they talk about probability too, like, okay, what's the likelihood of this thing going to happen if this happens, like things like that. And statistics is the science of collecting data, analyzing and interpreting data. AI relies on statistical models to learn from data and make predictions. And we all like statistical models that we know of, regression model and regression, the descriptive statistics, prescriptive, and things like that. So AI uses all these things to, it's like the bedrock for which AI is built. Like all these things are like, they are all interconnected to make AI like really work. And they said this is a foundational mathematical discipline that provides the framework to understand and manage uncertainty, manage predictions, and learn from data. And it's just like AI uses all these things to help us make life easy, to give us responses to prompts that we give it. It looks at it from a problem, and it works at the speed of light. That's just the beauty of AI. This thing, it's not like we humans can do it. We can do it. We have the ability to do it, but the speed at which we do it is not compared to the speed at which AI will do. That's the main difference that I see to it. Like people will have different opinions as to the use of AI and then we humans, but it's still the same thing that we humans do. That's okay. This is it. We humans do this thing. We humans do this thing, but we just don't have the speed. We don't have that speed to do it. Look at it, processing data and things like that. Before the emergence of AI, we've been writing our projects very well, and people have been presenting their project and then making it look so great. Like you see some projects and like, is this person human at all? I know we've come across different projects and all, and then we've seen how it works, and we've seen the content and the authenticity, the how rich the project is. Like, I'm talking about like school project that people do, and then even like, I know during my own time, my supervisor, when he saw someone's project, he was like, well, I think I need to publish this. This looks so good. And at that point in time, we don't know. That was like 2017, 2018. AI was not something that we actually knew about. That would have said, oh, maybe she used AI to do it. So these things, it's just the speed at which AI does it that's just like the major difference. Aside that, we actually like we know all these things. We definitely know it, but AI just does it in a way that is just fast, and then we get to like enjoy it and all. Like, so I said in this place, AI make predictions, never certainties. I was trying to like understand this thing, like, how does this happen? It makes predictions. It's just like, okay, how does this thing work? It's never like, it will tell you like, and as I put this example here, like it says, if you go to ChatGPT right now, I don't know if you have your phone with you, go to ChatGPT right now, check. Even Cloud AI too, like another example of this thing. That's some, yeah, cloud AI. If you go there, you'll see it right under the screen. Like, they will tell you ChatGPT can make mistakes, check important info. So it's just like, it's what it's giving you is not like it's 100% certain. It's just based on the likelihood, it's based on the sequence, it's based on like the analysis of what it has done to actually like tell you, okay, this is my response to it. And it's telling you that it can make mistakes also. It's just to show you that AI is not perfect, as people would think it is. It's not perfect. It still needs the human, what do you call it? The human aspect of it. Now, the other part, they said that probabilistic. So I want to talk about the probabilistic and statistical models in AI. Now, the first one, like I said, regression analysis is used to identify relationship between variables, and the Bayesian statistics is used to estimate the probability of an event based on prior knowledge and new data. Now, if you look at it, these things actually like explain the way AI works. This is so relatable in the sense that we look at it and you're like, okay, when you give AI a prompt today, like, I don't know if you've heard this thing before, but AI learns based on, they said it feeds on data that we actually like put into it. It feeds on our inputs. Like, it learns every day based on what we tell it. Like they said that you teach the model. Like, I've heard it before, they said teach the model. So this is what it uses. It uses these things based on prior knowledge and also new data. Then it just combines the two and then tries to like grab from this side, then look at it. Okay, what's the relationship between the two of them? Then it gives it out, takes prior data, gives it this one, and then just work everything out and then gives your answer. But the speed at which it gives it is just the dynamic part of it, because we ourselves, we can't look, before we can do all these things, we have to like sit down and start thinking 1 plus 5 plus 6 plus 7, and then before we know, we've done so much, we've wasted so many time, we've wasted so much time before we can actually get the answer we want. And also the Monte Carlo model, it's also like probability of different outcomes, like complex system using random sampling and things like that. And also the Gaussian processes. I just saw this. I was trying to read about it, but I was like, okay, don't let me explode right now. Because when I saw this, I was like, wow. So there are different things that I don't even know, like, that exist in this world. And also, but that's just it basically. That's how probability and statistics, that's how they work in AI. That's how they actually like factor into, that's how they serve as the building block of artificial intelligence. Now let's move to calculus and optimization. We are almost done. Sorry, I talk too much whenever I'm talking. I don't know. Calculus. Now, calculus, we did this when we were in school. I did further math a bit, so I learned calculus, differential calculus, and all, like the y, the x. Yeah, I feel so proud of myself right now saying all these things, because at that point I was like, why are you stressing me with all these things in this life? Like, of all things to learn is the y, the x I should be learning right now. I want to study accounting. You're telling me the y, the x. How does this thing apply to me? But I'm very grateful to those that sat down, that learned this thing, that actually like said, okay, we're going to use this thing to make life better. Like, thank you so much, because who would have thought that this thing I was actually like running away from when I was differentiation and integration. Yeah, I was trying to look for that word since differentiation and integration, the y, the x, and things like. I was running away from all those things at that point in time, not knowing that these things are going to be the foundation of what is actually saving lives right now. Is the foundation of what is making life easy for us. What is the foundation of what is making us like be more efficient at work. Because, yeah, did someone say something? Okay, I think it's just like mute issues. So, like looking at it, calculus is when we're doing at that point in time, we felt like, oh God, can this phase just pass? Like, I don't want to. I'm not interested in all these things. But look at where we are today now, talking about it. Here I am today talking about calculus. But one thing about me, one thing I'm happy about is I didn't make the statement that I'm never going to use math in my life. Like, I'm just happy I didn't make. If not, I'll be biting my fingers right now and hiding my head in shame. Like, look at what I actually said I'm never going to use in my life. Look at it saving life right now, making me more efficient at work and things. Now, calculus is the mathematical study of continuous change. AI learns by minimizing errors. Like if you look at it, come to look at it, linear algebra, probability and statistics, calculus and optimization. All these things, they are all interwoven together. If from the grand point of view, everything is all interwoven. We said that it learns. And how do you minimize error? Is by learning. And how do you minimize error? Is by looking at previous knowledge, like testing your previous knowledge and new data, and then trying to like make everything like make it look so good. So everything is just like they are all interwoven together. It's really great. Like it's really interesting seeing all these things and then just seeing that they are all interconnected to each other to make the whole, like to make it like stand, to make AI stand and then be what we all know today. It's just like the math behind it, like just sitting down, then you doing all this thing and calculus, integration, calculus, probability and statistics and linear algebra, they just sit they just sit at the back and they're looking at you like, okay, yeah, this is my son doing this thing. My son regression analysis is the one working right now. Calculus is like, oh, my son differentiation is the one that is at work right now. Linear algebra is like, oh, my son matrices is the one working right now. And then everything just works, and then you just get your answer within split seconds. Like sometimes I don't know if some of us just think about that. How does this thing just work? How is this thing working? That it's making that I ask it a question right now, and then in like 2 seconds, I have my answer already. Like, how does this thing work? It's the beauty of it. It's the beauty of math at work here. Like, math is just so fascinating. I feel like, okay, maybe if I come again into this world, I'm going to study mathematics. I don't know yet. I'm just saying based on what I'm doing right now. So don't quote me on that. Now, calculus, it is used to optimize models by finding the rate of change of errors with respect to different parameters and minimize these errors. Common example is when you give prompts repeatedly so that you can get the desired results you want from the instruction. Now look at it. When, I don't know, I wouldn't say I'm an heavy user of artificial intelligence, but I use it so well. Like I mentioned in Replit, in vibe coding. So the thing about vibe coding is that I'll take a step back to explain this example here. When I tell it to build an app and then it builds it, and then the next thing is, so I test it like from the back end. I'm like, okay, funniest thing, I don't need to have tech knowledge to be able to use Replit, to use Tray, to use all those things like that. You don't need tech knowledge. What you just need is, how do you want your app to be like? How do you want it to work? Draft an MVP or a PRD, product requirement description, which you can tell you can tell Cloud to generate it. You can tell Grok, you can tell ChatGPT to help you generate it, and then you go back into it and then check through again the human aspect of AI. We are not going to. I'm still going to talk about that part. Like it's a real great deal. And then the researchers among us, when you see the next thing I'm going to project, not for this one, in like the later slides I'm going to project, you will understand what I'm trying to say. Now, when I tell Replit, okay, build an app that is going to like help high school students with their general knowledge, with history and things like that, it builds it and then it gives me like an interface as to how I want it to look. Then I tell it, okay, add a section for user management. Then when it adds that section, or it adds a section for chats and things like that, so that you can like chat with your friends and then, or maybe create a challenge box there that you can like challenge your friend to doing this task together and things like that. And then it actually uses, and then it creates that section in it, and then you click on it and it gives errors. You go back again and tell it that, okay, I just clicked on this place and it is giving error 404, fix this. It goes back again, works on it. If there's still another if there's still any other mistake that you can see or you need an adjustment, you tell it again, like, do this. So that's how it works, such that if I load the same PRD again back into Repli, like 2 years later, it's going to work on based on what I've given it, and then think about it like, okay, it will even ask me that, do you want to add this section to it? Do you want to add this section? Do you want to add? Because it has learned from it has gotten it from its pool of knowledge, like, okay, this, let me bring it together to make something tangible. And then, do you think this is what you want? It will ask you like, okay, do you want to proceed with this updates, or do you want to proceed with this additional feature and things like that? So it learns, you give it prompts repeatedly, and then it acts, and then it is true. And then all these things work through the use of, like, it uses calculus theories like differentiation, integration, and things like that. Like, if you had to go deep into it, I wanted to like add it, but when I saw the way it's like you have to go deep dive into all those things one by one. I'm like, okay, me deep diving into this is going to it's going to take like the whole day. This thing is just for further study. Like what I would say, there's always room for study. There's always room to learn more about things. Like, it's so interesting that when you start reading about it, you would want to learn so much about it. And then you can also learn all these things through the use of AI. AI will actually tell you, this is how calculus and integration works for me. This is how it works. This is how it makes me work. This is how probability and statistics help me in carrying out your task. This is how these things help in doing, like, it just gives you an overview. It just helps you, like, it makes everything easy for you to understand and all. So without wasting much of our time, this is like the whole math behind AI. There are still so many things that we can actually talk about, but for the sake of like myself and everybody and everything, basically, we just want to talk about these three things, which is the linear algebra, probability and statistics, and calculus and calculus. And that's how all those things actually like work together. Like, they are all interwoven, basically. It's none of them is standing in its own. They all work together to actually help make life easy, to make us efficient at work, to help us minimize time that we spend on doing tasks and all those things. Like, they are all interwoven. Linear algebra, probability and statistics, calculus, everything, they are all together, and then that's just it. Now, let's move away from the old math and everything. Let's move into, for those that are not mathematically inclined, I want us to now move into the aspects that we can actually, that we see, because this is like the part we can see of AI. I just talked about the part we can see of AI. Now, let's talk about the part of AI that we can see, that we actually work with every day, the human side of AI. Now, look at the picture. There, it says human plus AI is greater than AI alone. That's the fact. Like, that is the fact about it. Like, AI cannot stand on its own. It can't do things on its own. It's not like it has to, there's supposed to be a human factor in it, and then it learns daily from humans. Like, it learns and learns and learns and learns and learns. If you look at the story, or if you look at Iron Man, let me use the example, Iron Man. Jarvis, get me my suit. That's when it comes. And then whenever we talk, I wanted to see my Alexa is here, but it's going to answer me. But if you call out its name and then give it what to, that is when it acts. It can bring up suggestions like, okay, I just saw that the weather for us here, it's like mine just makes that beeps and pom, and it's like, okay, what is it? What's the notification? It tells you, okay, there's going to be a thunderstorm today from this time to so time in this area. It tells us, but it's because I've actually told you that whenever there's things like that, let me know, so I can know how to plan my day or what to expect or how things are going to turn out. And it cannot, and also human and AI, it's just like the collaboration of the two of them that makes it like it's actually greater than AI alone. We need the human side to AI, like it's needed. So they said the human-centered AI ensures it is built on human values, enhancing human capabilities rather than replacing them. which people are actually saying, oh, it's going to replace human, it's going to replace human, and things like that. It's just going to make life easy for us, basically. Fostering trust and collaboration between humans and machine for a beneficial future, not just for now, for a beneficial future. It is actually a collaborative effort. It's a collaborative effort. AI, human work together and make things easy for us. AI alone is not sufficient. Without the knowledge of math, there won't be AI that we talk about today. Basically, that's just the bitter truth. Like, so for if you know anybody that is saying that, oh, I'll never use math again in my life, point them to this direction and tell them that this math they are running away from is what you guys are enjoying right now on your mobile phones. You are enjoying right now in the cars. You are enjoying right now in the hospitals. You are enjoying right now on your Google Maps. Basically, like it's our everyday life. It's part of our everyday life. So if there's anybody, if you hear anybody saying all these things, please point them back. Just tell them, don't say things like that. AI is the one that is math is the one that is making all these things easy for you. Like without math, there won't be anything of all. There won't be AI today. Yeah, I remember something right now. The person that like drew the map that helped build Google Map, is it build Google Map or that helped with like doing all those things? He said it's a woman and she used math to do it. All the old latitude 9, 10, 15, 25 degree and things like that. They use everything was like it was true math. Like even in math, we even learn longitude and latitude. So basically, there's no way we can escape all these things. It's just part of our everyday life. And kudos to those that are actually still in the field trying to like work on different things to make life easy for us. Thank you so much. Now almost done. I said this like now key principles of responsible use of AI. Now you are to use AI, but use it responsibly. This was from Microsoft 2025. And then it says auditing and accountability, safety and reliability, transparency and explainability, fairness and inclusiveness, privacy and security. Now, AI has to have all these things. It must be safe and reliable, even though you still need the human factor. It must be transparent. Excuse me. It must be transparent and be explainable. Like there are so many prompts that we use in AI today that some people don't know. Now, there's one that I found out like some months back, I think earlier this year. They said that if you want to like explain something to yourself, like if you wanted to explain a certain concept to you on ChatGPT, just put ELI 10 and then put the concept there, put the subject matter there. It's going to, so that ELI means like explain like I am 10. So you can use ELI 5, ELI 15, ELI 50, and then he explains to you based on the age that you give it. And I'm like, sometimes I look at it and I'm like, how do you explain all these things? But it's just, that's just the beauty of it. Like, that's what we learned in the first part of this presentation, the all building blocks of it, the linear algebra, the probability and statistics, the calculus part of it, fairness and inclusiveness, like it must be fair. Now, this thing actually like applies to humans also, like you, and also privacy and security, like it must also like, even though like there's still so many talks about this aspect of it, like privacy and security, that's why so many companies built their own AI models, like may have their own. Deloitte has its own, I heard KPMG has its own, like different companies now like leverage on their own AI such that they tell you that they restrict it to things, like they tell you that, okay, even when you want to use it, they tell you that do not put client data on this thing. They don't do this because it's something that the issue of privacy and security is like has gained so much traction in the past few years. I worked on data breach and all those things in like last year, and when I saw this time, I'm like, damn, like there is so much to be done in this aspect of privacy and security. Like it's something that needs constant improvement. AI alone can't do this thing. Like AI alone, we need to play our own part also to ensure that our data, our information is private and secure. Like we need there's still so much to be done. We hear about AT&T, different companies getting like having privacy issues and all like that. So now, safety tips for using artificial intelligence. I'll tell you, use AI, use these things. They are for your own good. Nobody will say, and one thing I will say is that there's nobody on this earth there's nobody that is like technologically inclined. I wanted to say everybody before, but there's nobody that's technologically inclined that will say, oh, I'm never going to use AI, or I've never used AI in my life before. The phone you are using has some of those features that you don't know about, has those AI features that you just don't know. Is it the complete text form, the complete text, or the text, what do you call it? The text prediction or text correction? Do you think that's just like it's just the phone acting up, or the phone just doing its own thing? No, that's part of AI. Or should we now talk about Google Maps or Maps itself, like Waze and things like that? All those things, they are all from artificial intelligence. Like they are all artificial intelligence. And that's just basically like we can't run away from it. And there are some safety tips for using all these things. You can't just wake up and say, okay, my address is blah 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 blah. Blah. This is blah, blah. No, no, you can't do things like that. There are safety tips. Even if you check online, they will tell you, hammer it into your head over and over and over and over again. And the main aspect is the whole part of the human aspect, like human oversight, and the part of like privacy and secure and privacy, confidentiality, and security. Like those two parts are like the main things that they talk about when talking about like using artificial intelligence. Now, the first one is mind your inputs. Do not overshare. It's not right for you to like go there and then say, oh, my this one is this one, and then start sharing your life story and then telling that, okay, if you want to share things like that, there are ways at which you can like do it. Like, if you want to like paraphrase, or you want to like tell it to make your text so unique, so beautiful, use the right words for you, and you have names of people, you have this thing, you can just change the name of the company, change the name. Like don't overshare. You don't need to overshare to be able to use AI. Like limit the things you share, and then it can actually work on all those things. So far, you like give it the right inputs. Like this is what I want you to do, and it gives you based on that. Like what I'll say, garbage in, garbage out. What you give it is what it will give out. But for the case of AI, if you put in garbage, put in rubbish, like input rubbish, it's going to give you beautified rubbish. That's just it basically. It's going to work on it, make it look so good. And you'll be like, oh, so this is the trash I even put here. It's going to make it look so clean. And I'm like, okay, this looks so good and things like that. Be privacy aware. All AI often scrape data from the internet. If you go to cloud right now, or you go to Grok, or you go to ChatGPT, those are the three main examples that is always coming to my head right now. If you go to all those things right now and you put in a concept like explain this thing to you, it will see searching the web for things, searching, and then whatever you put on the internet, whatever data you put on the internet is for public use already. That's just it. So if you are thinking like, oh, I just put whatever you put there, it's already for public use, like it's already going to take it like that. So be privacy aware, know what to share. Like it's just everything is just dependent on each other. AI is a tool. Every tool needs human input and oversight. Even if you go to a factory and then they want to like produce plastic bottles, they need to specify the sizes they want, which is the human input for it. So AI is just a tool. Every tool needs human input and oversight. So you need to like check. And that's why in some companies they have the role of the quality control. Like even though there's going to be the aspect of like you checking on the system, like, oh, this specification makes sense, this thing makes sense, there's still the human side of it. So do not ignore that aspect. We'll see it in the next slide. I'm going to say, don't overlook that aspect. It's something that I've heard over and over again. Like, do not overlook the part of human oversight. Like, always make sure, like, whatever prompt you give to you, whatever response you get from all those things, verify. As we will say in audit, trust but verify. Trust but verify. Verify all those things, because you wouldn't want to wake up tomorrow and then they tell you that, oh, what you did is not real, is fake, and things like that. Be safety conscious. It's just dependent on the other ones too. Verify responses that are AI generated. AI can make mistakes. AI hallucinates. Like AI hallucinates. Not it's so let me explain this hallucination part. It's just like you trying to tell ChatGPT, like, okay, generate this thing for me, and then it looks at it. It wouldn't want to tell you unless it's the only reason it wouldn't give you the response is if it's like going to violate human rights, or it's going to violate like laws and things like that. That's when it's not going to give you. But if it's something that is like it's like, okay, I want to give you this response. It's going to give you, but the response might not be real life example, because it's just going to look at that. Let me pick from this. Let me use linear algebra, probability, and then calculus. Let me take all these things together, process this data, learn from what I have in the past, then build up something. It just builds up a case from the Bloom, and then from Limbo, and from everything from the cloud, and it just gives it to you and be like, okay, this is it, just to make you understand, just to drive home the points. AI would not tell you no unless it's like violating human rights, it's violating laws, violating regulations and things. So far it's legal, it's going to give you an answer. Basically, it's going to look for an answer to give you and then tell you this is it. Now, this is where I was like this is where I wanted to talk about. Now, another, the safety, the aspect of human oversight should never be overlooked. Should never, I should have put this never in caps lock, in capital letters, in bold, in underline, in italics. Change the color to red, change the background to like yellow, like just to make it like, just for us to see this. Like, even though we've talked about the back end, the back side of it, we that we are using it outside, that we are going to like, that we don't necessarily do the linear algebra, the calculus, regression, and the regression analysis and all. We need to like take these things into cognizance. Like, we should not overlook this aspect of human oversight. There are so many cases of AI hallucinations over the years. Now, these cases, they are legal cases. If you look at all these cases, you can write down any of them, or you can even take a screenshot of this case and check. Every one of them talked about AI hallucinations, like AI creating cases that are not like in existence. If for those of us that like did a bit of law, I did business law back in undergrad, and to tell you, like, as in the case of FRS versus Mr. Lamidi versus FRS, it will tell you the case, and then just judicial precedent, like tell you all those things, like this is it. Now, for these people, when they wanted to like they used AI to generate cases, like generate responses to cases, and then the judge found out that what they did was, those cases do not exist. It was just AI bringing up all those cases from the blue, because based on what they said, like, okay, I need a case that talks about the Apple suing Nokia for this and that, and then it's just like, oh, does that exist? Okay, let me look for something. You can just bring out the case of like Motorola and BlackBerry. It might not exist, but it's just going to bring out something, and then just bring up names, bring up cases, and then just give it to you. And then they found that, and it actually cost these people their job. So the fact that AI is actually helping us make life easy, it can also be the downfall of man also. So the thing is that make sure you actually like check through everything you do. Like, human oversight is needed. Like, it cannot be overemphasized. Now look at this thing, this case here. That's why I said those the people that those that write project and all, you will see this. Look at this case. You can actually take a look at, you can take a screenshot of this case, Google it, and then you will see this thing there. It was retracted. I saw this on LinkedIn yesterday, and I had to go do my own check. I was like, oh, maybe this person is just trying to like explain a concept and things like that. But no, this case was retracted. It was these people actually wrote an article, and look at it. I want us to, I don't know how to zoom this thing, if I can zoom it. Oh, I can't zoom it. But look at it. On that, from the introduction part, it said, certainly, here is a possible introduction for your topic. Even from the first part of it, we don't need to read through to know that they use generative AI to write their projects. Like, they didn't check through it, and this thing was published. So it passed through, I don't know the stages of like you publishing articles, but it passed through the review, it passed through the publication stage, it passed through the maybe secondary review or detailed review stage. The process of preparing detailed review, secondary review, analytical review, any type of review that you do, it passed through all those stages without them catching this, and then they published it until somebody now brought it to their attention. Like, these people use generative AI like to generate, and look at, they would have actually come out the next time like, yeah, we published our article, it's on Science Direct. This was actually from Science Direct. It's on Science Direct. Yeah, we've published our own article. I have an article to my name and things like that. Not knowing that you actually shot yourself in the leg. Now, these people now, if they publish like their articles tomorrow, expect it to go through like serious level of scrutiny before they can even accept. That's if they are not like banned from it already. Like if they are not restricted from publishing and thing. I don't know if they do that, but if they're not restricted from publishing. So the aspect of human oversight cannot be overemphasized. Let's always continue. Let's always put that at the back of our mind. That whatever we do, let's always make sure that we do our own quality control. We do our own quality control. Now, this is the last slide for me today. AI is powerful because of math. It is not magic. There is no magic in AI at all. Like there is no magic at all. Like if anybody's telling you, is magic, is black magic, is white magic, is yellow magic, is pink magic, and it's not magic. It's just math. And math is like what we've learned so far. It's just all those things that we've learned back in school that somebody like actually sat on and then developed it and then used it to create something like this. And I said, look at the last sentence here. I said, that is why it is called artificial intelligence, not natural intelligence. There's a difference between the two. We know there's a difference between artificial and natural. Like it's artificial intelligence. So there's still like the aspect of mistake, aspect of you trying to like verify things and all like that. So that's just it. So this is the end of my presentation today. And I don't know if you have questions and this thing. That's my email address if you want to reach out to me, and on LinkedIn also. So thank you so much, Dr. Idayat. The floor is yours.
Thank you, thank you, thank you. In fact, we really appreciate your brilliant presentation. So, to the participants, do you have any question to ask our speaker? The floor is open for questions. Are you there? Our participants, please, you are free to ask questions. Ask your question now before our speaker just leave us. Any question? Any question?
Would I say I did a good job?
All right. Yes, you really, in fact, today's your topic is I really have so much interest in it because I'm into data science
Okay.
and I really understood all what you said. Basically on linear algebra aspects.
Mm,
I know we use linear algebra to formulate our data
yep.
set,
Yeah.
especially when we want to formulate our data set. So we make use of that uh, the aspect of linear algebra, basically the vector and matrices.
Mm.
So I really love this. Your presentation is very, very fantastic, and you really done a good job. Thank you so much. We really appreciate you.
Thank you.
And to our organizer, in the person of our prof, thank you so much for giving us this opportunity again to at least participate in this wonderful presentation, our third webinar lecture. Thank you so much, all the participants. Really appreciate you, and God bless you all. Thank you.
Okay, thank you so much, Mr. ID. We are very, 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 very grateful. That was, I mean, a mathematician would probably only, I mean, like I don't know how to even explain this. You have done an excellent job, basically, like, and that's so inspiring. Thank you so much. Like, I was just talking to myself that if you are brilliant, you are brilliant. Like,
Yes.
no matter what is anything, like
Yeah.
you did a very, very excellent job, and we're very grateful for that. I think,
Yeah.
Black in Mathematics Association is it was founded by Dr. Adejimi, who happens to be in the house right now. I don't know if he has something to say. Definitely. Let me not even give him the option. Just Oga talk.
Our prof talk. Oh.
Yes.
Really
Thank
done
you
a
very
very good
thank
job.
thank you very much, Dr. Danso.
You're welcome.
Thank you very much as well, Dr. Idayat, for doing an amazing job. And thank you very much, Mr. Toluwanimi. The name is very interesting. It's
Yes. Toluwanimi.
yeah. Thank you for the session. You actually took something that is complex and
Yes.
explained it in a simple way that is chewable and yet is at the same time reproducible. Thank you so much for that. Yeah, this is Black Mathematics Association. It's a combination of researchers at different fields, which contains of researchers at the level of their undergraduate, ones at masters, PhD professors, and senior lecturers. So we all come together and do quality research and have webinars like this in order to train ourselves and also expand our skills as well. And to be honest, this that you have done, it's something that we won't forget. We really appreciate. We know how busy you are, but at the same time, thank you very much for doing this. God bless you. And a great thanks to our organizer, our boss for this ham in person of
Professor.
Dr. Dansu. We call him Dr. Danzu.
Which
And
boss again? When the boss day?
and great work, Dr. Idayat, for doing
Thank
so
you
much.
so
Thank you
much.
so
Thank you
much.
so much.
Yeah.
Yeah. Yeah,
Yeah.
welcome, sir.
Yeah. Over to you.
All right. I
Like,
mean, I mean, there was no question, Seth. Can you imagine? Like that was a thorough job, well done. So I think the only thing I just want to do before we go, we have this quarterly. Yes, yes. Before I forget, okay. In fact, I think this is a very big opportunity. In Black in Math Association, we have webinars monthly. I mean, sorry, we have the webinars quarterly, and then we have
totally.
5 use spaces at least twice a year. In fact, this year we've had 4 of such. But interestingly, on the 1st of October, we'll be having a 5 use space forum where we have some very powerful scholars joining us. I'm trying to see if I can quickly get. I have the link. Just made the link today. So although the flyers will be out very as soon as possible, but I think people can start signing up already. So I just want to quickly share that before we sign out. Let me quickly look for this. So there will be we have the Pivot Space Forum. So the normal Pivot Space we have accomplished mathematicians Black mathematicians, by the way, across the world, people who have been there, done that, as far as math is concerned. So if you check the box now, you'll find the link. So you can start signing up already. You can start sharing it in your groups and everything. So the flyer will be out very soon. So there we have, in fact, if I open this, we have some very interesting. So we're going to have like a panel discussion. We have Professor Emmanuel Bakari from Ikamda in Oyekiti, Nigeria, Professor Abdon Antangana from University of the Free State in Bloemfontein, South Africa, Professor Jude Kong, University of Toronto, Canada, Dr. Jimmy David, she works with Pfizer in Cambridge, USA, and Dr. Kayode Shinubi. Yes, I mean, thank God for Dr. Kayode, who connected us to our speaker today, who has done an excellent job. So he is going to be one of the panelists, and I'll be moderating that session. So you want to sign up right now and share it so that you don't miss out. I mean, that's exactly 1 week from now. The flyer should have been out already, but I mean, we are trying to make sure that happens soon. So on a final note, I know maybe some people are just
No one is raising hand.
okay. Someone okay. Who's that?
Next, yes, the floor is open.
Please go ahead.
We are listening.
Okay.
Thank you very much. Thank
All
you
right,
very
nice.
much, sir. Thank you very much, Mr. Toluwanimi. It was a very
We can
wonderful
just
session.
slap him a Gatorade now.
Yeah, okay. I asked a question earlier on, though it's not directed to Mr. Toluwanimi now. I'm directing it to Mr. Dr. Emmanuel, sir. Can we have access to the materials he shared? One, and then two. I just saw the link to this particular webinar on a friend status, and that was how I signed up. And now you're saying it's something that happens often. So I want to, is there like, can you share with us a group link where we can probably join the group on probably WhatsApp or Telegram so that we can be more informed, or is there a way to follow this BMA association like full time? Because I studied mathematics. I just finished my
Wow, lovely,
undergraduate, and I'm really, really interested in the concept. Funny how
lovely.
2 days ago or 3 days ago, I actually saw Dr. Adejimi's profile on LinkedIn, and I was reading it. I was like, oh wow, this is actually nice that we have people like this coming up with initiatives, or that have things like this in place for way back here in Africa, we here in Nigeria, people that are already over there. So now that I have the opportunity of being with all of you here, I'm asking if you guys can help us with the link, or a way to join the association. Like I said, I just finished my undergraduate program, and I see this as a pathway to meeting greater minds in mathematics, doing greater exploits in mathematics. So I really appreciate that if the link can be dropped or something, or a way we can sign up to be members of this association or to belong to the group later on, sir, please.
Yeah, we have a Telegram group. I'm trying seriously. I don't think I'm an admin on that group. So maybe, I don't know if Dr. Adejimi can help us post the link to our Telegram group. In that group, we have like 338 mathematicians, and we regularly share opportunity scholarships and things like that. So I hope we'll be able to. I'm seriously, frantically looking for it right now.
Yep.
But I guess I may not have the. I may not have. Oh, I'm an admin. Interesting. So how do I share
Yeah.
this? I'm an admin here. Wow, how come I'm just knowing now? Let me see. I don't know. How do we share links on Telegram?
I think if most of the time I refer them to Victoria, probably with their contact, then Victoria had them automatically
Okay.
there. Yeah, because I think it's being done in such a way that it's only admin that can add in order to,
Oh, right.
yeah, because at the initial stuff, people were not
Hmm.
obeying the rules and things like that. So to mitigate that, totally admin. So perhaps if he can send his digits to your email or my email, then from there his digit can be sent to Victoria, then Victoria will add them automatically to the Telegram group.
Okay, so did you get an email, Mr. Nelson? Did you get an email sending you the link to this meeting, right?
No, I did not get an email. A friend helped me with that. When at the time I registered, or I clicked on the link to register, it told me that the program wasn't accepting responses again. Then I messaged the person on whose status I saw it, and the person asked where said she
Oh,
would get back to me,
Dr.
and
Danso,
then I
I
think
Right.
guess
she got
maybe he saw
confirmation,
it on
and then she uh,
Sajidat's
yes, yes, I saw it
status.
on
Okay.
Sajidat's status. Yes, I saw it on
Okay. No,
Sajidat's
no
status.
worries. Just shoot me an email. I'm dropping my email address right now. ej@gmail.com. Then we can take it up from there.
Thank you very much, sir.
Yeah. So by exactly 1 week's time, we will having View Space Forum, where we have okay. Let me see if I can display. I can just show that briefly. Yes, trying to share my screen. Then having done that, I'll just continue to this. So can you see this?
Okay. You can all see
Yeah.
it.
Yeah, this is the Youth Space Forum 2025 coming up next Saturday, 4th October. So we have these powerful mathematicians, talking about mathematical modeling of infectious disease and epidemiology in Africa, the past, the present, and the future. So you want to sign up already if you can, and let's have a nice time again, taking care of that. Right. So let me stop sharing. And so the last thing I just want to do is that we have this webinar quarterly. So this is the third one this year. So in the last quarter, maybe sometime in December. In fact, I think we have one or two other events coming ahead. So after the View Space on Saturday, I think our next event should be, maybe we have a couple of View Spaces in between. And by December, we'll be having an Epiverse training. I think Epiverse is a tool. I don't know about it really, but we have some people from the London School of Health and tropical medicine. So they use that tool for for epidemiological modeling. So you may want, so just watch out for that. So for people like Dr. Nelson, I don't know. So if you're free to send me an email, then we can. So else we'll find a way to get into the group, and then you keep abreast. I mean, there are more things we do. For instance, we have a research group. Since we started, we've published about 5 or 6 papers, and we have like 6 papers or 7 papers. So we have groups like that. We distribute people into groups and they work on projects. So the last thing I want to do, in case you're wondering, how do you, if you want to have a part in this whole AI thing, of course, first of all, if you're a mathematician, you are already starting out, right? So so this is a bit personal, and I know I have the permission of our convener to share this. I have a YouTube channel where I have several playlists on different aspects. Everything that I've been talking about today, like uh everything that has been. Can I mute? Okay. Okay, nice. So I have thought I have different playlists on statistics, probability, linear programming, calculus, everything that has been mentioned today. I have videos on them, and then interestingly, I also have some for anybody who is interested in data science and you want to start from the very scratch. Say you want to start from Microsoft Excel. I have a 45 video playlist on Microsoft Excel. From there, I have a 60 video playlist on Python basics, and then from there we move on to data analysis with Python, and from there to SQL for database management. Afterwards, we have something on what else now? Data science. If you want to go all the way to data science, especially focusing on machine learning, I have 60 videos on that too. So if you're interested in that, I'm sharing my link to that. So you can just sign up to the YouTube channel. That's the first link you see there. Then you can see so the next I think from there you can now, if you want to see the playlist and everything, you can click on this one after the other. So on that note, we've come to the end of this. We hope we can see you again next week as we come for View Space, where we have that interesting panel discussion. Once again, Dr. Toluwanimi Idowu. Maybe we are prophesying into your future. I don't know. So thank you so much, because you did a very, very, very powerful job, and we pray that you go in leaps and bounds. Thank you for sharing. Thank you for your time. We do not take it for granted at all. Once more, Dr. Idayat Usamot, thank you for your willingness.
Thank you.
Grateful for your sacrifice.
God
And
bless you.
Thank you so much. See you next time. We can see. Bye. So, Dr. Idowu will be on again. Like, now that we are in contact, so from time to time we'll be in touch. Have a very,
Bye, everyone.
Goodbye.
See you again.
Thank you. Bye.
Yeah.
Okay.